relative figure based on the Kelvin temperature. And then the last one there is color rendition, and that's how well a light source renders the actual colors of the object you're looking at, your eye seeing. So we're going to talk about how important that is and how we need to really drive that up. You want to maximize that number. That one, you know, you would like to be close to 100 if you can afford it in your energy budget and such. Some illumination recommendations. Now there's an organization that sets these standards. It's the Illumination Engineering Society of North America. And this is they produce a handbook every year, and this is a very brief synopsis of one of their parts of their handbook. They really detail indoor spaces to death. I mean, they talk about first the space type, and then they talk about the tasks in each space and all the different tasks that could be done in the task, and they assign a different range to each one of those tasks. So they really, if you really want to get into it heavy, get one of those handbooks, and they can really define it for you. But some basic ones that we use at the university all the time are up here, the top three. We've got either a workstation or not a workstation. Like we're in here, we don't have workstations, so this is more like a reading and writing area. The recommendation is like 50-foot candles. Now again, that's measured right at the work surface. So you buy yourself about a $100 light meter, and you can do this yourself and measure these and make sure that you're not over lighting spaces, which I need to mention is a big problem with new construction. When we go into facilities at the university, we almost always find that we're overlighting spaces, and some of the case studies I've got later on show some of that. But these are some basic numbers, and you can see how low it gets when you get outside and site lighting, roadway lighting, anywhere from 0.3 to 1.6 foot candles. I think we're somewhere around a 0.5 for a minimum and a 0.8 for an average, or vice versa, I think. Besides coming up with some recommended foot candle levels, IES also publishes a list of criteria that they think is important for design considerations. And I encourage you to think about these things when you're doing these retrofits. The color, we talked a little bit about that. We're going to talk more about that coming up here. The color of how your eye really sees, because your eye is not seeing the color coming out of the light, it's seeing out of the lamp rather, it's seeing whatever you're looking at. It's a reflected light coming at you. So it depends very much on the table. Like these are dark tables in here, and so we're getting a lot less reflected light. If they were real light, we could lower the light level and still save energy and still have the same kind of appearance with our eyes on the work surface. Daylight integration and control. I think that's important, and IES is also behind that. It's really taking advantage of our environment when there is that availability there, and having some automated controls or manual controls to reduce power consumption when we have that outside light. Glare is something where direct glare comes from when we have too intense of a source, and the most common place you see that is when you're at a window and you're using the natural light and you've got direct sunlight coming in that might be too intense for you to use really, and it needs to be turned down a little bit. Light distribution is a really important one. IES recommends about a 3-to-1 ratio, not to exceed about a 3-to-1 ratio on interior spaces. So what that means is if we have a general 50-foot candle in here, we don't want to be lower than 15 anywhere, and we don't want to be greater than 150 anywhere in here. So it's a 3-to-1 ratio there, and then outside is about a 10-to-1 ratio they recommend attaining. So you have a lot more flexibility when you get to the outside environment when you're doing site lighting. Luminance of the room surfaces, we talked about that, and whether you're, so we're talking about your floors and your wall coverings and stuff. If you can lighten those up, that allows you to lower your power density of your lighting while your eyes are still perceiving the same light level. Points of interest in here, we've got pictures on the walls and things like that. We might need to light those. Reflected glare comes from those surfaces. It's not as big a deal now as it used to be. It used to be a problem with the CRTs, everybody having the CRT monitors and it really reflecting light. Now with the flat plasma screens and the LCD screens, it's not as big a problem. Shadows, smart. Yeah, that's good for now on that. System control, we're going to talk about that. This is, remember I talked about how the science of how the eye works is changing. They're starting to gain a greater understanding. The DOE actually paid General Electric engineers to study the eye and how it perceives natural light, and came back that everything we thought we were following in the practice was wrong. It was always thought that the eyes contain rods and cones, and the cones were used for nighttime vision and the rods were used for daytime vision. And it turns out that it's much more complicated than that, as I would expect, that both of them get used simultaneously at all times. And it really has to do with the color spectrum. So the cone, or the photopic part of the eye, is more in tune with the blues with the higher frequency lights, and the scotopic, or the rods, is more in tune with the lower frequencies, and they overlap nicely to give you a nice final product. And so the reason I put this up here is because since they had this perception that everything was daytime was all scotopic, that they built the light meters. Remember I talked about the $100 light meters? They built all them to only operate in that range, in the scotopic range. And so now I have these arguments with, like I'm going to talk about one later on, it's parking garage lighting retrofit, where we go in there and we take one of those cheap light meters and it doesn't read the proper level because we've shifted the light so far to the right that we no longer are getting the levels. So we ended up having to pay for a $1,000 light meter that covers both these spectrums. And so that's something to consider when you start getting into odd situations with your code officials and things, and you feel like you're right, you might have to prove it with something like that. Color rendering index, this is a critical one. This is the one I talked about. You want to try to drive to 100 if you can afford it. This is really dramatically shows, although this projector is not rendering it as well, but it shows you how dramatic this change is. So above our eyes here, we're seeing about a 50 to a 70 CRI. And then from here down, I think most of us could live with this kind of color, but a lot of our early office lighting projects were up here in the top, and that produced a lot of resentment, for the people in spaces. They really had a lot of problem with that. And so we really ended up getting a bad rap over that, kind of using those products and not considering all these different engineering aspects of light fully. So I really encourage you to look at this kind of thing and make good decisions about it. And you can see it's pretty easy nowadays. Inside of office, you're going to be either a T8, T5, or a CFL. And so as long as you try to stay out of the the 70s on the T8, you'll be fine. Other than that, you're going to end up with a really nice product, where it used to be a much more difficult problem. And then the color temperature, this kind of shows where the different products lie, and incandescent really hits home. I mean, it did back here as well. You see incandescent went up here at a 98 CRI. That's why incandescent had such a stronghold on the market, because it really produces nice light. It really renders well, and it also has a very normal color temperature, where it's not real warm, and it's also not at all cool. Where the fluorescent technology can be way out here, and it can produce really a negative feedback, from your customers when you get out there. And I had another example I'm going to tell you about there on that parking garage related to the color temperature as well, where I had an interaction with the administration. This is the linear fluorescent. This is really the workhorse of the industry, of the commercial buildings. You've got them all throughout your facilities. And this shows kind of the progression where we started back here. When I started in the industry, we were in the T12 stuff and with a magnetic ballast. And I just found a building the other day, downtown Orlando, that we own that is full of these things right here. So we're all over that right now. But this shows, I'm sorry.
Pine
Yeah.
Street?
Where?
Pine Street?
Yes. You know about it?
I put them in there.
Oh, thanks. Pine Street still has them. It won't for the next couple of weeks, but it's going to be going away. Yeah, they're still working. So the progression, I mean, hopefully everyone's into T8s now for the most part. I know we are at the university, but it shows the dramatic savings. I mean, just to get to T8, we're looking at a 35% reduction. So these numbers, the first three columns there, are all about a 4-light 2x4 troffer. And then we step over to these next three where we delamped. We removed about half the lamps in the fixture. And you can see how the foot candles went down a little bit. So we were 28, 20, 25, 30, 27. So a little bit of a reduction there. But look how why is it at Nancy? Look how it, because I'm touching it. Yeah. how it dramatically reduced the wattage and in turn the savings. So we're down all of a sudden 67% reduction from the original T12. It's not really a fair comparison because hopefully we're somewhere over here right now. So I didn't do those reductions, but you can still see that's a tremendous reduction just in that step right there. And so what we did here is we added a reflector to the fixture, like these fixtures right here need. They are painted white surfaces. They're not very reflective. So we're going to see in later slides how about 50% of the light is being trapped up there in that fixture. It's not really getting out to the work surface at all. And that's what this dramatic shift is here. It's delamping and it's also adding a reflector. Next, we added an occupancy sensor to that same fixture. And then finally, we talked about maintaining it. And what do we mean by maintaining a fluorescent light fixture? We're talking about cleaning mostly, right? Cleaning the reflective surfaces, cleaning the grids, and cleaning the lamps even, as well as doing group relamping. So keeping everything the same age. Really a proponent of that, although we're not always doing that at the university. Now the efficacy, remember we talked about this is related to the efficiency of a light bulb. It's not really efficiency because efficiency is where you take the same kind of units and you do a ratio of the two, and so it's a unitless, you end up with a unitless ratio. Where this still has units, we're taking light intensity and we're dividing it by electrical wattage input. And so you can see this is where the downfall of incandescent shows up. That's why they're being banned. They're sitting between 10 and 15 on this scale, whereas fluorescence up there at 98 in some cases. HID even greater. HID has great applications in our outdoor lighting and big box stores and such. What else do I got on here? CFLs, good CRI, but not so good on efficacy. The other big surprise is the LED. A lot of people are surprised to see how low that sits on the efficacy thing. Where LEDs really shine, though, is when we put them into a fixture, though. So we're going to see how they get moved up a little bit when we get them installed into a fixture. But the lamp itself, not so great. Okay, here's a typical PAR fixture, whatever, recessed fixture. And here we're seeing this is an incandescent bulb, but it could just as well be a CFL in there. And I'm saying here that about half of its light is trapped up in that fixture, even though it's a white painted fixture. It's amazing how much doesn't get used by that. And it's kind of similar to these type of fixtures. A tremendous percentage is trapped up in there. The other thing to note is that of this 50, so let's say we started out with 1,000 lumens of this light. It's say it's a 100-watt light bulb and it produces 1,000 lumens. So 500 of them is getting just stuck inside the can. 500 again is coming out. Now out of those 500, how much actually hits the work plane? Probably about 2/3 of that will hit the work surface. Another third of that is lost. So what are we down to, about 266 or something like that out of 1,000 that actually make it to do the work that we're trying to get the light bulb to do. That kind of begins to show how powerful task lighting can be. The other thing to consider with fixtures is reflectivity and direct versus indirect, and then we already talked about wall and floor surfaces. This back panel back here looks real nice. I mean, it's a nice wood fixture for the mayor and everything, but it really sucks up the light, you know, and we're having to increase the light levels in here just to compensate for that. Kind of a systems approach we talked about before, but want to hit it again. We're looking at how do we get our environment, you know, really good, considering both productivity and energy costs. Well, we want to look at light levels first and foremost. We want to control glare. We want to get a good color for our people. Uniformity, I hit on that, how important that is, that we don't have these dark, this little area over here, I keep looking at it, it's really dark, and it's because of that. I think it's mostly because of that wood paneling, but we have some challenges here with uniformity. Natural light versus artificial, and really taking advantage of the natural light. And then finally, energy efficiency. And energy efficiency, again, remember, not just the lamps, but also the drivers that are driving the lamps. Sometimes they're called ballasts, sometimes they're called drivers. But that plus the fixture. And finally, the finished system.